Okay, Assalamualaikum warahmatullahi wabarakatuh. So untuk lecture week 2, okay, for reaction kinetics, okay, I will cover 1.1 reaction rate and 1.2 collision theory. Okay, so for week 1, you all dah belajar 1.3 factors affecting reaction rate. Okay, so for this week, I will cover 1.1 and 1.2. Alright, so this is overall lah learning outcome, okay, for this chapter, okay, 1.1, 1.2 and 1.3. So untuk 1.1, okay, yang Madam bulatkan tu adalah C1 and C2. Okay, tapi for lecture, Madam akan cover A, B, C and D sahaja. Okay, and then the rest kamu akan belajar dalam kelas tutorial. Okay, untuk 1.2, okay, 1.2 semuanya adalah C1 and C2. So, Madam akan cover semua sekali lah untuk 1.2. Alright? Alright, so kita tengok dulu what is the learning outcome for 1.1. Okay, Madam akan ajar A sampai D saja. Alright? So, A, define reaction rate. B, write the differential rate equation. C, determine reaction rate based on differential rate equation of a reaction. Okay, so this is C3. Okay, tapi Madam akan cover sekali lah. Okay, senang. Okay, and then D, define rate law, order of reaction and half-life. Alright. So, jom kita start. Alright, so for introduction, chemical kinetics. What is chemical kinetics? It tells us the speed at which the chemical species transform into new substances by breaking and reforming their molecular bonds. Okay, in other words, it studies the rates process and processes of chemical reaction, which is the rate of reaction. So, bila kita cakap pasal kinetics, what is kinetic? Kinetics refers to movement or change during a reaction. Alright, so this is the application in daily life. Fireworks exploding, combustion of fuel, okay, food be going bad and rusting nail. Banyak lagi lah sebenarnya, okay. So the next one. Alright, so kita terus pergi kepada learning outcome A, define reaction rate. So the reaction rate, what is the reaction rate? So this is the definition of reaction rate. Reaction rate is the change in the concentration of a reactant or a product with time. Okay, so it involves reactant and product. Okay, both. Right. So for the unit, for the reaction rate, okay, rate tu unit dia adalah molar per time. Okay, so molar per time here. Okay, so time is refer to the second, minutes, hour, day, okay, and so on. Right. So rate is inversely proportional to the time. Okay. So for example, we have A produce B. Okay. So the rate here is equal to negative D concentration A over dt. Okay, the concentration A. Negative here shows that the concentration of A will decrease over time. Okay, and then the rate for B, okay, is equal to positive dB over dt. Alright. So you must put the positive sign for the product. Okay, so kalau ada produk lebih daripada satu, so kita akan letak semua positif, and then for the reactant must put the negative sign. Okay, produk bertambah, okay, sebab tu kita kena letak positif lah. Alright. So for example, okay, ni secara gambaran lah, okay. For example, A produce B, okay, at the beginning, okay. So let's say the black dot here is refer to the reactant. Okay, and then for the at the beginning B memang tak ada lagi lah. Okay, so the as the time goes by, so the concentration ataupun the red dot there, okay, become increase. Okay, while the black dot become decrease. Makin lama makin sikit A. Okay, B bertambah lah. Okay. So it shows that the concentration of the reactant will decrease, okay, and then for concentration of product will increase. Okay, so kalau kita tengok dia punya graph macam ni lah, okay, untuk A will decrease, for the concentration of the product will increase. Okay, so tadi Media dah terangkan, okay, ataupun Media dah mention reaction rate is inversely proportional to time. So the shorter the time taken for the reaction to progress, okay, the higher the rate of reaction. Okay, itu kita cerita pasal rate. Okay, so what is the differential rate equation? So ini adalah learning outcome yang kedua, B. Okay, a differential rate equation enables the relationship between the rate of disappearance of reactants and the rate of appearance or the formation of product. So bila dia suruh buat differential rate equation expression, so it involves both, okay, reactant and product. So you must put, first of all, you must put the word rate here. Okay, so rate is equal to negative 1 over A. Okay, A kecil ni menunjukkan apa? Menunjukkan stoichiometric coefficient. So kita kena letak 1 over A, dA over dt, D concentration A over dt. Okay, is equal to negative 1 over B dB over dt equal to positive. So the product must put the positive sign because the product will increase. Okay, and then 1 over C dC over dt equal to positive 1 over D dd over dt. Okay, so you must put the negative sign for the reactants and then the positive sign for the product. Right. So for example, okay, the formation of ammonia, okay, nitrogen gas react with 3 mole of hydrogen gas produce 2 mole of ammonia. So what is the differential rate equation for this reaction? So it is equal to rate. Okay, rate is equal to negative dN2 over dt equal to negative 1 over 3. So di sini nitrogen gas dia satu kan. So kita payah letaklah 1 over 1. Okay. And then for hydrogen gas, okay, we have 3 here. So negative 1 over 3 dH2 over dt equal to positive 1 over 2 dNH3 over dt. So what does it mean? Okay, the equation means that the rate of disappearance of what? Nitrogen gas is equal to 1 over 3. Is 1 over 3 the rate of disappearance of hydrogen gas equal to 1 over 2, okay, rate of formation of ammonia. Okay, so itu maksud dia. Right, so kita tengok example. Okay, consider the reaction. 2Hi produce hydrogen gas and iodine. Write the rate expression for the reaction. Okay, number 2, determine the rate of disappearance. Okay, dia minta rate of disappearance of Hi. Hi adalah kita punya reactant. When the rate of I2, okay, when the rate of I2 formation, okay, is 1.8 times 10 power negative 6 molar per second. Okay, so kita tengok dia punya solution. Okay, so the expression, the differential rate expression for this reaction is rate is equal to negative 1 over 2 dHi over dt equal to positive dH2 over dt equal to positive di2 over dt. Okay, so kena tulis the bracket here, it shows the concentration. So kena letak bracket yang petak ni. Okay, tak boleh yang biasa. Alright, and then number 2. Okay, so number 2, given that, okay, the rate of formation of I2 is equal to 1.8 times 10 power negative 6 molar per second. Okay, so the question asks for the rate of disappearance of Hi. So we just relate, okay, with the related question. Maksudnya sekarang diminta Hi kan. So we just relate with, okay, Hi dengan I2 yang dia bagi adalah I2. So tak payah melibatkan hydrogen gas lah. Okay, so kita just tulis macam ni, rate is equal to negative 1 over 2 dHi over dt sebab ini soalan yang diminta. Okay, rate for the disappearance of Hi and relate with the I2 sebab I2 yang dibagi maklumat. Okay. So, kita tulis balik, okay. So, the negative sign here shows that the rate of disappearance, okay. So, 2 kat sini kita bawa sebelah kanan dan darabkan dengan 1.8 times 10 power negative 6. So, kita akan dapat 3.6 times 10 power negative 6 molar per second. So, we can conclude that the rate of disappearance of Hi is equal to 3.6 times 10 power negative 6 molar per second. Okay. So dalam soalan ni dia bagi second, so kita just ikut saja. Alright. And then D, okay, kita tadi dah cover yang C sekali lah, okay, kita terus buat pengiraan untuk yang LOB, okay. So sekarang kita terus pergi kepada D. Define rate law. Tadi adalah differential rate equation, okay, it involve both of the reactant and product. But then for this one, okay, rate law, okay, kita tengok pula macam mana dengan rate law. Okay, rate law ataupun dalam arti kata lain adalah rate equation. So rate law is the relationship of the rate of reaction to the rate constant, okay, rate of reaction to the rate constant K, and the concentrations of the reactants raised to some powers. Alright. So it involve only the reactant. So dia tak melibatkan produk lah. Okay, raised to some powers. Okay. So the rate, okay, rate directly proportional to the concentration of reactant, okay, power of order. Okay. So nanti kita tengok what is the order of the reaction. Okay, so how to write the rate law? So the rate law is equal to, for this case, okay, rate is equal to K. So you must put K here, okay, the rate constant, okay, times with concentration A power of X, okay, and concentration B power of Y. So K is the rate constant. So what is X? What is Y? Okay, X and Y tak ada kaitan dengan coefficient, stoichiometric coefficient ni. Okay, so X and Y adalah order. Okay, X adalah order for for A, for the compound A, and then for Y is the order of B. Okay, so dia punya reactant dia ada order masing-masing. Okay, boleh jadi sama, boleh jadi berbeza. Okay, and then the overall order for this reaction, sebabkan kita ada dua reactant kat sini, so kita akan tambahkan saja order untuk setiap reactant, dia akan menjadi overall reaction order. So X tambah Y sahaja dapatlah overall order. Okay, so kita tengok sekali lalu untuk rate constant. What is the rate constant? Rate constant is a constant of proportionality between the reaction rate and the concentration of reactants. Okay, this punya definition. Okay, tapi dia bukan tak ada dalam LO lah. Okay, cuma Adam akan explain lah. Okay, so the rate constant and its value depends on a specific reaction, temperature and catalyst. Okay, so the larger the value of K, rate constant tadi, the faster the reaction proceeds. Okay, so kalau kita ada dua nilai apa tu, yang berbeza, so kita tengok yang K yang tinggi nilainya dia adalah the faster the reaction. Okay, so unit of K is depends on the order of the reaction. So kita tak ada spesifik yang betul-betul. So kita akan tengok dulu what is the order of the reaction, baru kita boleh tahu what is the unit of K. Okay, tengok order lah, bergantung pada order. Alright. And then tadi rate law. Okay, and then sekarang kita tengok what is the definition of order of reaction. Okay, order of the reaction is the power of reactants or concentration in the rate law. Okay, yang X dengan Y tadi, which define how the rate is affected by reactant concentration. Okay, so for example, we have A plus B produce product. So the rate here, so this is the rate law yang kita baru tengok tadi. Okay, K concentration A power of X, B power of Y. Okay, so X dengan Y ni adalah order of the reaction yang Madam dah mention tadi. Okay, so the X and Y are generally small, positive or negative integers. Okay, and then it's only can be determined experimentally. Okay, secara eksperimen saja kita boleh tahu dia punya order. Okay, so dia tak ada kaitan dengan coefficient lah, okay, of the reactant. So order of reaction is always defined in terms of reactant concentration, okay, not product. Okay, tak ada kaitan dengan product. So the order of the reactant is not related to the stoichiometric coefficient, tak ada kaitan dengan stoichiometric coefficient, okay, of the reactant in the balanced chemical equation. For example, okay, so kita tengok equation ni. So fluorine gas, okay, react with 2ClO2 produce 2 FClO2 gas. Okay, so kita nampak kat sini ada 2 mol ClO2, tapi rate law dia ditulis sebagai rate is equal to K concentration F2 and then concentration ClO2. Okay, so that's mean tak ada pun power of 2. Bermakna tak ada kaitan dengan dia punya stoichiometric coefficient. Alright. Right, for example, okay, sekarang kita nak tengok determine the reaction order from the rate laws. Okay, from the rate law, macam mana kita boleh tahu dia punya order? Okay, for each of the following reactions, determine the reaction order with respect to each reactant and the overall order from the given rate law. Okay, so rate law ini yang merah ni adalah rate law. Okay, merah ni adalah rate law yang dia dah bagi. So kita just nak determine the order of the reactant and the overall order. Okay, so this is the solution. Okay, untuk yang pertama, okay, the rate law, okay, is right as K concentration NO2 power of 2 concentration O2 power of 1. So the reaction order with respect to NO is second order sebab dia tulis 2 kat sini. So it is second order for NO. Okay, and then what about O2? O2 is first order sebab kat sini power of 1, so tak perlu tulis 1. Okay, so it is first order. So what is the overall order for this reaction? The overall order is third order. Okay, B, CH3CHO produce CH4 plus CO. Okay, so your rate law given there, rate is equal to K concentration CH3CHO power of 3 over 2. So the order of the reaction, okay, the reactant CH3CHO, okay, is 3 over 2. Okay, and then samalah dia punya overall order sebab dia satu-satunya reactant yang ada. Alright, and then C, we have 3 reactants here, H2O2, I minus and H plus. So given the rate law, rate is equal to K concentration H2O2 and then concentration I minus. Okay, dia tak tulis concentration H plus. Kenapa? Okay, so dekat sini kalau kita tengok H2O2 power of 1 tapi dia tak tulis. So kalau power of 1 tak payah tulis, and then I minus power of 1 juga. Okay, maksudnya both of the reactant H2O2 and I minus is first order. Okay, and then what about H plus? Dia tak tulis sebab apa? Sebab, okay, untuk H plus, okay, kalau bila tambah kat sini, dia tak tulis sebab dia power of 0. Okay, anything yang power of 0 maksudnya sama dengan 1. Okay, so bermakna sebab tu dia tak tulis lah. So that's mean the H plus, the order of H plus is equal to 0 order. Okay, so the overall order is second order. Okay, H plus tadi adalah 0 order lah. Alright. Alright. So, kita tengok pula satu-satu, okay? So, kita cover hanya 0 order, first order and second order, okay? So, consider the reaction A produce product, okay? If X is equal to 0, okay? So, rate is equal to K concentration A power of 0. Okay, so anything power of 0, okay, adalah bersama dengan 1, okay? So, bermakna rate is equal to K. Okay, so that means rate is not depends on concentration of A. Okay, kita tambahlah, kita multiply lah banyak mana concentration A, so dia tak ada effect pun pada rate. Okay, so that means, okay, the reaction is 0 order with respect to A. Okay, so kalau kita tengok apa-apa yang kita multiply double ke triple ke that concentration, and then tak ada effect pada rate, that means it is 0 order. Okay, and then if X is equal to 1, okay, the rate here is equal to K concentration A power of 1. Okay, so first we assume that, okay, sekarang ni kita nak tengok apa kaitan concentration dengan rate, okay, untuk yang X sama dengan 1 ni. Okay, kita buat dulu kalau concentration A yang initial adalah sama dengan 1 molar. Okay, therefore rate 1 is equal to K concentration K1. Okay, ni kita masukkan nilai concentration tadi. So if the concentration A is double, okay, double maksudnya daripada 1 tadi, made double kan, so dia akan jadi 2. Okay, so it become rate 2, our rate 2 is equal to K2. Okay, so kita keluarkan 2 ke hadapan supaya kita nak samakan balik ini adalah sama dengan rate 1 tadi. Okay, sama dengan rate 1. Okay, bermakna rate 2 kita adalah double, okay, with the rate 1. Okay, dua kali ganda. Bermakna kalau kita double the A, okay, it will double the rate of reaction. Okay, so dia akan follow lah. Okay, so bila kita tengok trend macam ni, okay, the reaction is first order, okay, with respect to A. Okay, Sebab dia follow. Double, dia akan menyebabkan rate 2 pun akan double juga. Okay. Nanti kita tengok lagi contoh. Okay. If X is equal to 2, okay, rate is equal to K concentration A power of 2. Okay. So, assume that the concentration, the initial concentration is equal to 1 molar. So, rate 1 is equal to K, the value of the initial concentration 1 power of 2. Okay, so let's say kita double the concentration of A, okay, from 1 become 2. So, kita cuba masukkan kita punya new rate, rate 2 is equal to K, the value of the 2, okay, 2 power of 2. Okay, that's mean kat sini kita nampak bila 2 kuasa 2 sama dengan 4 lah. Kita relate with the rate 1. So, 4 kita bawa ke hadapan. So, dia akan jadi K1. Okay, nilai yang asal tadi. So, that's mean yang ini adalah apa bersamaan dengan rate 1. Okay, bersamaan dengan rate 1 yang mula-mula tadi. Okay, this one. Okay, yang ni. Okay, so bermakna dekat sini, okay, doubling the concentration of A, okay, the rate will increase by factor of 4. Okay, or 4-fold or quadruple. Okay, so bila kita tengok trend macam ni, okay, therefore the reaction is second order, okay, for A. Okay, so kita tengok example 2. Okay, tengok example 2. The reaction A plus 2B produce products was found to have the rate law. Rate is equal to K concentration A and concentration B power of 2. Okay, so ini kamu boleh tengok pada kamu punya nota lah, ada sama je. Okay. So predict by what factor the rate of reaction will increase when the concentration of B is double. Okay, concentration B is double and the concentration of A remain unchanged. Okay, so dekat sini kita tengok, okay, untuk B, okay, B bila double, so dia akan jadi, kita tulis balik, okay, kita tulis balik rate yang baru. Ini katakan rate yang pertama. Okay, bila dia berubah macam ni, kita cuba buat, okay, dia akan jadi rate yang kedua lah. So, rate is equal to K. A tak berubah. A remain unchanged. So, dia masih sama. And then B, dia jadi double. So, dia letak 2B. Okay, double. Power of 2. Alright. So, bila kita kaitkan balik, kita cuba keluarkan, okay, kat sini K concentration A. So, 2 power of 2, so dia akan jadi 4 lah dekat sini. So, B kita kekalkan power of 2. Okay, kita keluarkan 4 tu ke hadapan. So, dia akan jadi 4K concentration A. Okay, concentration B power of 2. So, yang ini dia sama macam rate 1. Okay, so bermakna rate 2 kita adalah, okay, dia 4 kali ganda lah. So, by what factor? So, dia adalah increase by factor of 4 ataupun kita boleh kata 4-fold. Okay, so buat macam ni saja. Right. And then example 3, kita tengok given rate is equal to K concentration NO2 power of 2 Cl2, by what factor does the rate increase if each of the following changes occurs? Okay, sekarang kita tengok. Dia kata rate kita, the rate law given there, so NO2 is triple. Okay, so kalau NO2 is triple, so kita tulis balik. So this is A. So rate is equal to K. Okay, untuk NO2, so dia akan jadi triple. Okay, NO2 power of 2. Cl2 dia tak buat apa-apa, so kita salin je balik Cl2. Maksudnya dia remain lah. Okay, so dia akan jadi, okay, apa dia? Okay, so kalau kita tengok kat sini, 3 kuasa 2. So dia akan jadi 9 lah. So kita terus letak 9 dekat depan. Tulis balik NO2 power of 2 and then Cl2. So kita akan dapat yang ini adalah yang asal tadi. Okay, yang rate yang mula-mula yang dibagilah, katakan rate 1. Okay. So bermakna kalau kita tengok kat sini, dia kata, okay, so apa jawapan kita? It increase, okay, by factor of 9. Okay, the rate of reaction, okay, the rate of reaction is increased by factor of 9. By factor of 9. Okay, and then B, NO2 and Cl2 are double. Okay, so our new rate 2 is equal to K concentration NO2 2 here, okay, and then power of 2, okay, power of 2 kenapa? Sebab dia dah bagi yang asal kan, okay, and then Cl2 pun kita doublekan, okay, dua-dua double sekarang, okay, so apa yang kita nak buat sekarang, so dia akan jadi dekat sini, keluarkanlah K kat sini 2 kuasa 2 4 kan, so dia akan jadi NO2, so kita keluarkan kat sini 2 Cl2. Okay, so kita darabkan 4, okay, darab dengan 2, so dia akan jadi 8. So kita akan tulis kat depan K concentration NO2, ni power of 2 tadi. Okay, NO2 and then Cl2. Kita keluarkan balik, okay, keluarkan yang ni sama macam rate 1 tadi yang mula-mula. So kita tengok dia akan increase by factor of 8. Okay, itu sahaja. Okay, alright. So ini madam go through sikit untuk unit for rate constant K. Macam mana kita nak tahu unit of K daripada order. Okay. So untuk zero order, okay, kita tengok daripada rate law untuk zero order K concentration A power of 0. Okay, let's say kita ada reaction A produce product. Simple saja. Okay. So katakan kat sini zero order power of 0 lah. So bermakna power of 0 is equal to 1. So rate is equal to K. Macam mana kita nak tahu dia punya unit of K? From rate is equal to K, we know that the rate here, the unit of rate is molar per time. Okay, molar per time. So bermakna unit K sama dengan unit rate. Sebab K sama dengan rate kan. Kita dapat macam tu lah. So molar per time. So untuk zero order, unit of K is molar per time. Okay, molar per second, molar per minute, semua boleh. Okay, and then it depends lah pada case. Okay, and then for the first order rate is equal to K concentration A power of 1. Okay. So kita dah dapatkan sekarang the unit for K. So kita tulis balik K is equal to rate over A. So A adalah concentration. So tulis dalam unit dia concentration. So kita boleh cancel out and kita akan dapat dia punya unit of K is equal to per time. Okay. And then for the second order, okay, rate is equal to K concentration A power of 2. Okay. So K is equal to rate over concentration A power of 2. So concentration power of 2 adalah bersamaan dengan molar over power of 2. So kita boleh cancel dekat sini. So kita bawa naik atas molar, so dia akan jadi per molar per time. Okay. So untuk order yang berbeza, kita ada unit K yang berbeza. Okay. Right. And the last one for 1.1 untuk mana cover dalam lecture ni adalah half-life. Okay. What is the definition of half-life? Okay. Mana tahu rasanya mana dah pernah belajar kan? Okay. Cuma kita refresh lah balik. Okay. Half-life is the time required for the amount of reactant to decrease to half. Okay. Time required. Okay, time required is about the time required for the amount of the reactant. Okay, decreased by half. Alright, so amount here, okay, they refer pada concentration, mass, moles, atoms, molecule, and so on. Alright. Okay, so you just have to memorize the formula of the half-life for zero order, first order, and second order. For zero order, concentration, initial concentration of A, okay, over 2K. K adalah rate constant tadi, okay. Yang A naught ni adalah initial concentration. Okay, and then for the first order adalah formula half-life dia adalah ln 2 over K. Second order, dia punya half-life adalah 1 over K initial concentration A. Okay, ingat saja formula. Tak ingat formula, tak boleh buat. Itu je. Formula tak diberi dalam exam. Okay, so for example, okay, the decomposition of ammonia, okay, dibagi kat sini is zero order, okay, with the rate constant, okay, rate constant dibagi 2.5 times 10 power negative 4 mole per liter per minute. Okay, mole per liter adalah bersamaan dengan molar lah. Okay, so the reaction equation is given. Okay, write the rate equation for this reaction. Rate equation sama dengan rate law. Okay, and then what is the half-life of the reaction when ammonia is 0.75 molar? Okay, diminta half-life. Okay, kita kena tahu, first sekali kena tahu what is the order of the reaction. Order dibagi adalah zero order. So you just use the formula for half-life of the zero order reaction. Okay, and how fast? Okay, how fast ni diminta rate. Okay, how fast is a 0.475 molar of ammonia being changed to nitrogen and hydrogen? Alright, so we look the solution. So, untuk, okay, kita tengok untuk zero order, okay, rate is equal to K sahaja. Okay, sebab zero order di power of zero. Okay, B, diminta half-life. So, half-life, you guna formula untuk zero order, concentration A over 2K. So, just substitute the values, okay, kita akan dapat, okay, 1,500 saat. Okay, 1,500 second. Okay, and then C, okay, diminta how fast, okay. How fast kita kaitkan balik dengan rate law. Rate is equal to K, so tak ada kaitan dengan concentration, okay. So terus dapat rate adalah 2.5 times 10 power negative 4 molar per second. Okay, example 2. Okay, given there the decomposition of ethane C2H6 to methyl radicals is a first order reaction with a rate constant 5.36 times 10 power negative 4 per second. Okay, so calculate the half-life of the reaction in minutes. Okay, diminta dalam minutes. Okay, so just use the formula for the first order ln 2 over K. Okay, substitute the values and kita akan dapat dalam unit second. Okay, sebab dibagi K dalam second. So, kita convert it into minutes. Okay, so kita tengok apa yang kita dah belajar tadi, the differential rate equation. Okay, consider the reaction. So differential rate equation expression is given there. It relates with all the reactants and product. Okay, don't forget to put rate, the word rate here. Okay, and then the negative sign and the positive sign as well. Right, and then the rate law, okay, or rate equation, it involve only the reactant. Okay, involve only the reactant. Okay, and then X and Y adalah order for reactant, okay, A and B respectively. Okay, for summary of the kinetic of zero order, first order and second order, let's say we have A produced product. For the zero order, rate law is equal to K, okay, and then the unit of K molar per time, half-life is given there. Okay, so this is the summary for our 1.1 yang kita dah belajar tadi. Alright. So you have to memorize the half-life. Okay, the formula. Alright. And then we go to the second part, 1.2, collision theory. Okay. So this is the learning outcomes for the 1.2. Okay, kita ada 4 sahaja. Explain collision theory, define activation energy, explain the transition state theory, and draw the energy profile diagram of a reaction. Okay, kita tengok yang pertama. Okay, explain the collision theory. Collision theory is the theory to explain the rate of chemical reaction. So it based on the rate, okay, directly proportional to the number of effective collisions, okay, and inversely proportional to the time. Okay, so the collision theory is based on the ideas, dia ada dua, okay, molecule must collide to react, okay, and the collision involved is an effective collision. Okay, requirement for the effective collision. Okay, ini pun soalan biasa masuk. Okay, what is the requirement for the effective collision? Okay, molecules must possess a certain minimum kinetic energy or activation energy, okay, to initiate the chemical reaction. Okay, number 2, molecule must collide in the correct orientation in order for the reaction to occur. Okay, minimum energy and correct orientation. Okay, so minimum energy, what is the minimum energy here? Okay, the activation energy, okay, is the minimum energy, a minimum amount of energy required to initiate the chemical reaction. Okay, so reactant untuk dapat produk, dia mesti sama atau lebih daripada activation energy or the minimum energy, baru dia boleh jadi produk. Okay, Okay, itu yang dimaksudkan sini tadilah. Okay, must possess a minimum energy for the chemical reaction to occur. Right? And then, what is the correct orientation? Okay.
Next, we look at the difference between an unsuccessful and a successful collision in terms of geometry. First, the reactant molecules approach each other. However, they collide with incorrect geometry, therefore no reaction takes place. And finally, the reactant molecules separate. Next, we look at the successful collision. So once again, the reactant molecules approach each other, but this time they collide with the correct geometry, a chemical reaction takes place, and the products are formed.
Alright, so itu menjelaskan what is the correct orientation, ada successful and unsuccessful reaction. Okay, and then we go to the next one. Okay, draw energy profile diagram of a reaction. Okay, reaction profile shows potential energy plotted as a function of the progress of the reaction. The difference in potential energy between the product and reactant is delta H, okay, for the reaction. Okay, so we have two types. Okay, ada dua. Okay, sekarang delta H ada positif and ada negatif. Kita akan tengok nanti. Okay, and reactant molecules must have enough energy to overcome an energy barrier separating product from the reactant. Okay, EA. Alright. So, kita tengok dulu. Yang pertama adalah exothermic reaction. Okay. Tu yang dikata tadi, delta H is difference between the product and reactant, the energy, the potential energy of product and reactant. Okay, product tolak dengan reactant. Okay, so untuk exothermic reaction, the delta H adalah negative. Okay, so we have two EA here. Okay, yang pertama adalah, okay, bila reactant produce product, kita ada EA for forward reaction, okay, and then kalau dia reversible reaction, the product become reactant, so kita ada EA reverse, okay. So the difference between the product here again, okay, here is delta H, okay. So we can relate tiga benda ni, EA forward, okay, delta H and EA reverse. Okay, so ini satu lagi raja, okay, iaitu kita tengok kat sini kita ada reactant and then kita ada ke atas sekali the highest potential energy here is transition state. Okay, pada transition state, okay, kita ada dua benda yang berlaku iaitu bond start nak form and then ada start nak break. Okay, so the species at the transition state adalah activated complex. Okay, kita panggil dia activated complex. Okay, so here the EA forward, okay, adalah daripada reactant. Okay, garis kat sini reactant and then until the top here, until the transition state, itu adalah EA for the forward reaction. Okay, and then reactant and product here, okay, kita tahu dia adalah delta H and then from the product to the top, okay, to the transition state, okay, adalah apa? EA for reverse reaction. Okay, so we can say here, okay, kalau kita tengok dekat sini, we can relate it, okay, EA reverse reaction daripada bawah sampai atas is equal to the summation of delta H and EA forward reaction. Okay. So, untuk yang kedua adalah endothermic reaction. Endothermic adalah delta H positif sebab apa? Product, okay, the energy of the product is greater than the reactant. Okay, so bila lagi besar produk tolak dengan nilai yang kecil, sudah akan dapat positif. Okay, so delta H is positif. Okay, so untuk endothermic reaction, konsep sama juga. Okay, reactant, okay, daripada reactant, sampailah ke atas ni, okay, dia bergerak ke sini lah. Okay, macam ni dia nak jadi produk. So, dia minimum energy dia adalah daripada reactant sampai ke atas lah. Baru dia boleh lepas jadi produk. Okay, for the reverse reaction, okay, from the product become reactant. So, dia punya EA adalah daripada product to the top. Okay, so dia adalah EA for the reverse reaction. So, product here, okay, the delta H here, okay, adalah di sini. Okay, the difference between the energy for product and reactant itu adalah delta H. Okay, so ini adalah sama sahaja. Okay, kita tengok example. For the reaction A plus B produce C plus D, the enthalpy change of the forward reaction is positive 21 kJ per mole. Okay, the activation energy for the forward reaction, okay, activation energy for the forward reaction. So maksudnya ini adalah EA forward, okay, forward, okay, is 84 kilojoule per mole. Okay, sketch the reaction profile of this reaction and B, what is activation energy for the reverse reaction? Dia minta EA reverse, okay. Kita tengok dia punya solution. So ini adalah dia punya energy profile diagram. Okay, dia bagi kat situ dia punya delta H is positive 21 kilojoule per mole. So it is endothermic reaction. Okay, and then dibagi EA for the forward reaction. Okay, EA adalah 84 kilojoule per mole. So kita lukis di sini. So we can relate it. Okay, EA forward, okay, EA forward daripada bawah sampai atas is equal to, okay, hasil tambah EA reverse, okay, dan juga delta H. So, macam mana kita nak cari EA reverse? Senang sahaja, okay, EA reverse is equal to forward, EA forward, okay, minus delta H. Okay, so masukkan nilai dan kita akan dapat EA reverse. Okay, so daripada energy profile diagram kita boleh buat kita boleh kira lah, okay, buat pengiraan dan kita akan dapatlah apa yang soalan diminta. Okay, and then example 2. The activation energy for the forward and the reverse reaction, okay, dia bagi activation energy untuk forward dua-dua dia bagi 127 kilojoule per mole and EA for the reverse reaction is 15 kilojoule per mole. Okay, draw and label completely an energy profile diagram for the reaction and calculate the heat change for the forward reaction. Okay, diminta heat change adalah delta H. Okay, diminta delta H. So kita tengok dekat sini dia bagi, okay, EA for forward adalah greater, okay, for the reverse is lagi sikit lah. So bermakna dia adalah, okay, endothermic reaction. Okay, sebab kalau kita tengok kat sini, okay, nilai EA for forward adalah lebih banyak. So tinggilah kan. So kat sini lagi sikit. So it is endothermic reaction. Okay, so we can relate it EA. So okay, so EA for forward, okay, kita look ke sini, EA forward, okay, adalah sama dengan EA reverse tambah dengan delta H. Okay, tengok ni kat sini pun kita dah nampak dah. Okay, hasil tambah ni adalah bersamaan dengan EA forward. Okay, so basically kita boleh carilah delta H. Okay, so jawapannya adalah positive 112 kilojoule per mole. Okay. Alright, so kita tengok LOC. Explain the transition state theory. Okay, so the transition state theory is used to explain in detail, okay, dia lebih detail, what happen when the reactant molecules collide with each other. Okay, so the configuration of the atoms of the colliding species at the time of the collision. Okay, so kita ada pada transition state, okay, kita ada spesies yang wujud dekat situ pada transition state, kita panggil dia activated complex. Okay, what is the characteristic of activated complex? So it is very unstable, okay, and has a short half-life. And then the potential energy is greater than the reactants or product. Kita tengok yang tadi kan, kalau kita tengok balik energy profile diagram tadi, paling atas sekali kan, okay, bermakna dia punya potential energy dia paling tinggi lah, greater than reactant and product. Okay, and then the activated complex and the reactants are in chemical equilibrium. Okay, itu dia punya karakteristik dia. And it decomposes to form product or reactants. Okay, maksudnya kalau kata forward, dia boleh jadi product and then from the reverse reaction, become reactants. Okay. Alright. So that's all for week 2. Okay. Thank you.